Welcome to the deep dive. Today, we're really zeroing in on something crucial if you're aiming for that senior software engineer spot in Java.
Oh, yeah. What's on the agenda?
Method and constructor references. Getting these right isn't just about ticking a box. It's about showing you really get how to write cleaner, more efficient Java code.
Absolutely. It signals a certain level of fluency with the language, especially its more modern features.
Exactly. So our mission today is practical. We want to cut through the theory and focus on how and when to use these effectively so you're ready for those technical chats.
Sounds good. So method references first.
Let's do it.
Okay. So think of them as like a super concise way to write certain lambdas.
Which one specifically?
The ones where the lambda just calls an existing method, nothing else. Method references strip away the boilerplate.
Makes the code's intention clearer, right? Less ceremony.
Precisely. It's about directness.
And constructor references, similar idea.
Kind of, yeah. They're shorthand too, but for creating new objects. So instead of a lambda that just calls new class name, you use the reference.
Ah, okay. I can see how that'd be useful with streams, maybe.
Definitely. We'll get into that. They really help keep functional style code clean when you need to instantiate things.
Cool. So the goal then is a solid grasp. Know them, use them, and importantly for interviews, be able to talk about why you're using them.
You got it. Ready to dive into the method reference types?
Let's go. First up is the class : instance method pattern.
Right. This one's interesting. Think about sorting strings, ignoring case.
Okay. Normally I'd write a lambda, maybe xy arrow x.com compared to ignore case.
Exactly. But with a method reference, you can just write string : compared to ignore case.
Huh. Much shorter. How does that work, though? Where do x and y go?
Good question. The compiler is smart here. It sees the context, like collections.sort or a stream-sorted method, expects something that takes two strings. So it maps the first parameter of the lambda, x in your example, to be the object the method is called on.
The receiver object.
Exactly. And the second parameter, y, becomes the argument passed to that method.
So x.compare to ignore case becomes string.com to ignore case. Makes sense. Very common in sorting, like you said.
Foundational stuff, yeah. Okay, second type. Class : static method.
Static methods. Okay, like utility methods.
Precisely. Think about checking for null. You could write x arrow objects dot is null x.
Right.
Or you can use the method reference. Objects : is null.
Cleaner again. And where would you use that typically?
A great example is filtering collections. Say you have a list and want to remove nulls.
List.remove f, yeah.
Instead of list.remove x, arrow objects dot and x, you just do list.remove if null if objects : is null.
It reads really well, doesn't it? Remove if objects is null. Very clear.
That's the power. Okay, third one. Object : instance method.
So this time, it's not the class name, but an actual object variable.
Exactly. You have a specific object instance already, and you want to call one of its instance methods.
Gotcha. Like printing things.
Perfect example. Think system.out. That's an object, right? A print stream instance.
Yeah.
So if you want to print every item in a list, you might start with list.forEach. X arrow system.out.printlnx.
But using this pattern,
It becomes list.forEach system.out : println.
right. For each element, call the print method on the system.out object.
And like you said before, it almost reads like plain English. For each system out print line.
Yeah, I like that. But wait, what if println is overloaded? Like it can take strings, ints, objects.
Ah, excellent point. How does it know which one?
Yeah.
The compiler looks at the context again and sees for each is operating on, say, a list string.
So it knows the element type is string?
Exactly. And based on that target type, the consumer string functional interface that for each expects here figures out you must mean the println string version.
That's clever. So it uses the functional interface's signature to resolve the ambiguity.
Precisely. It's all tied into Java's type system. It's not just syntactic sugar, it's type safe. Understanding that is definitely senior level insight.
Good to know. Anything else on method references?
Well, quickly we should mention capturing this. Inside an instance method, you can use this : for example.
Which would be the same as x arrow this dot equals x.
You got it. Useful in OO contexts, maybe comparing the current object against others.
Okay. And you mentioned inner classes briefly in the outline.
Yeah, you can even do things like enclosing class. This : method to refer to a method in the outer class from within an inner class. A bit more niche, perhaps.
And super too?
And yes, like super : to string to call the superclass version. We won't dive deep there today, but it's good to be aware these exist for those complex inheritance scenarios.
Okay, that covers method references pretty well. Shall we move on to constructors?
Let's do it. Constructor references. The core idea is similar. Concise creation. The basic syntax is just class name : new.
Simple enough. So for an employee class, it's just employee : new.
Exactly. Now imagine you have a list of, say, string names.
Okay.
And you want to turn that into a list employee, assuming employee has a constructor that takes a string.
Right, like new employee name.
You could use streams.names.stream.
And then the map operation.
So map name arrow new employee name.
That works. But with a constructor reference.
Map employee : new.
Precisely. .names .stream .map. Employee : new.
And again, the compiler figures it out. Because the stream has strings, it knows to use the employee string constructor.
You nailed it. It infers the constructor based on the stream's element type and the expected output of the map function. It ties nicely into functional programming.
That's neat. What about arrays? The outline mentioned arrays.
Right. You can make references to array constructors too. The syntax looks like, say, int square brackets : new.
Int.new. Okay. What's that equivalent to in Lambda terms?
It's like n arrow new int n. Well, n is the size you want. I see. So it's a function that takes a size and gives you an array. Why is this particularly useful?
Well, you know how Java generics and arrays don't always play nicely? Type erasure.
Oh, right. If you just call stream.toArray, you get back object, not the specific type you might want.
Exactly, which is often annoying. If you have a stream employee, you want an employee, not object.
So how do constructor references help?
The toArray method has an overload. It takes an int function a, which is basically a function that takes an integer size and returns an array of the desired type.
And the array constructor reference fits that perfectly.
Bingo. So you write stream.toArray, employee square brackets : new.
And that tells toArray exactly what kind of array to create. Employee.
It's a really clean, type-safe way to get the correctly typed array from a stream, overcoming that generic array creation limitation. It solves a common problem elegantly.
That is a very practical trick, especially useful in scenarios where you're interfacing stream results with older APIs, maybe?
Could be, yeah. Or just anytime you need that specific array type, it shows you know how to handle those Java nuances.
Okay, great. So pulling this all together then.
Method and constructor references. They're about conciseness, readability, making code express intent more directly.
Right. They replace simple lambdas that just call one method or one constructor.
You saw the 3 method reference types: class.instanceMethod, class.staticMethod, and object.instanceMethod.
And for constructors, className.new and the array version like type.new.
Key takeaway: using these effectively makes your code cleaner and often shows a better grasp of Java's functional features. Big plus for a senior role interview.
So as everyone listening prepares for interviews, think about where these could fit. Don't just use them blindly, but understand why. Be ready to say, I used a method reference here because it makes the intent clearer than the equivalent lambda.
Exactly. Articulate the benefits.
And maybe a final thought to leave folks with.
How about this? Consider the collaborative aspect. When you use list.removeRF, objects : is null. Instead of the lambda, it's instantly clear what's happening. It reduces the mental effort for the next person reading your code.
That's a great point. It's communication through code.
Right. So think beyond just syntax. How can applying principles like the clarity offered by method references make your overall code easier to understand, maintain, and collaborate on? That's a hallmark of senior level thinking.